Interceptors have many useful capabilities inspired by the aspect-oriented programming technique. This technique aims to increase modularity by allowing the separation of cross-cutting concerns. Interceptors achieve this by adding additional behavior to existing code without modifying the code itself. Interceptors make it possible for us to bind extra logic before or after method execution, transform the result returned from a method, transform the exception thrown from a method, extend basic method behavior, or even completely overriding a method, depending on a specific condition. For example, doing something like caching various responses. Alright, so to learn how interceptors work conceptually, let's run through an example use case where we always want our responses to be located within a data property and create a new interceptor to handle this for us. Let's call this new interceptor Wrap Response Interceptor. This new interceptor will handle all incoming requests and wrap our data for us automatically. To get started, let's generate an interceptor class using the nest CLI by entering nestg_interceptor common/interceptor/wrap-response. Note that we generated this interceptor in the common directory like we have many times before, since this interceptor isn't tied to any specific domain. Let's open up this newly generated wrap response interceptor file and see what we have inside. The nest CLI generated an example interceptor for us, without any business logic. Similar to providers, an interceptor is a class with the injectable decorator. All interceptors should implement the nest interceptor interface exported from Nest.js Common. This interface requires that we provide the intercept method within our class. The intercept method should return an observable from the RxJS library. If you're not familiar with RxJS, it is a library for reactive programming using observables, making it easier to compose asynchronous or callback-based code. RxJS itself is outside of the scope of what we can dive into here. Just know that it's a powerful alternative to promises or callbacks. Back to our code. The call handler interface here implements the handle method, which you can use to invoke the route handler method within your interceptor. If you don't call the handle method in your implementation of the intercept method, the route handler method won't be executed at all. This approach means that the intercept method effectively wraps the request response stream, allowing us to implement custom logic both before and after the execution of the final route handler. Alright, so we've covered a lot of theory so far. Let's add some console logs to see where interceptors fit in the request response lifecycle. Since we've called console log before calling the next handle method, our before message should appear in the console before the actual route handler is executed by the framework. Since handle returns an RxJS observable, we have a wide choice of operators we can use to manipulate the stream here. In this example, we're using the tap operator, which invokes an anonymous logging function upon graceful termination of the observable stream, but doesn't otherwise interfere with the response cycle at all. The data argument of the arrow function we passed into the tap operator here is in fact the response sent back from the route handler. Basically, think of this as whatever comes back from our endpoint. Here, we're just doing a console log to say after, and logging that data back as well. To test it all out, let's bind this interceptor to our application globally. Let's open our main TS file and add app.useGlobalInterceptors, passing in new wrap response interceptor. Great. Now, let's make sure our application is running in the background, and let's navigate to Insomnia and test any endpoint in our application. First, let's make sure we have some coffees stored in our database. To do so, let's hit the post coffees endpoint and add a random coffee. Perfect. Now let's hit the get/coffees endpoint and switch back to VS Code to see those console logs in the terminal. As we can see, before was logged and then after, followed by the actual value from our findAll method, which represents the coffee's endpoint. It looks like our interceptor worked. Let's open up Insomnia again and test another endpoint. Let's test coffees/1 this time. This time, we should see a single object following the after log in our terminal. Great, so far so good. So now that we can see how interceptors work and their part in the request-response lifecycle, let's implement our data wrapper idea we talked about at the beginning of this lesson and wrap our responses inside of a data property. To do this, let's replace the tap function with the map operator. The map operator takes a value from the stream and returns a modified one. Since we wanted to wrap all responses in the data property, let's return an object with a key value of data. Every time this map function is called, it returns a new object with a data property filled with our original response. Remember, everything we've done here is mainly for demonstration purposes, but hopefully now you can see the power of interceptors and how there's a potential to do so many other things here, like passing down version numbers, analytics tracking, etc., etc. All right, so let's save all of our changes, open up Insomnia, and test out this interceptor. Let's execute any HTTP request and see what the application sends back to us. Perfect. As we could see, the response was automatically wrapped in an object within the data property. So wrapping up, in this video, we've shown how interceptors give us an incredible power to manipulate requests or responses without changing any underlying code.